Okay, so this is a recording on how to do pre-lab question number 3 of the analysis of Alum lab. So pre-lab question number 3 asks you how many milliliters of barium nitrate would you need to add to Epsom salts to precipitate out all of the sulfate ions that are in Epsom salts. So the first thing I want to pay attention to is, well, how many grams of Epsom salts am I starting with? So you're told that you're starting with a mass of this hydrate right here that's 1.250 grams. After all the BSA tables that we've done, hopefully you realize that grams are not necessarily the place where you want to start. Moles are a good place to start. So before I do any calculations or any conversions, what I first need to do is I need to calculate the molar mass of the Epsom salts. Okay, so the molar mass of this hydrate, you have to consider both the ionic part and the water part. So if you were to add up magnesium, a sulfur, and 4 oxygens, you would get 120.38 grams per mole. 1 water is 18.02 grams per mole, so 7 times 18.02 is going to be 126.14 grams per mole. So the molar mass of this entire hydrate is 246.52 grams per mole. It's the anhydrous salt part plus the water part. Okay, so that's where that 246.52 grams per mole is coming from. Okay, so what you're ultimately trying to do is you're trying to precipitate out sulfate ions, these, as barium sulfate. Okay, so I need to first convert my grams of my hydrate, these grams right here, I need to convert them into moles. So that's why I calculated the molar mass on the last slide. Okay, so I'm going to keep a long dimensional analysis conversion here, but that will be the first thing you want to do, is you want to convert your grams of hydrate into moles of hydrate. And then you want to look at the hydrate, and I'm putting hydrate here because I didn't want to have to rewrite this entire formula. So I'm in 1 mole of the hydrate, I have 1 mole of sulfate ions. Okay, so I need to know, given a certain amount of sulfate ions, how much barium do I need to add in to precipitate out all of those sulfate ions? I'm going to make barium sulfate. So for every 1 sulfate ion that I have, I need 1 barium ion to precipitate that. So we're going to keep going with our dimensional analysis. So I was right here. So in the precipitate barium sulfate, right here, there's 1 mole of sulfate ions for every 1 mole of barium ions. And I was told right here, I'm getting my barium from barium nitrate, which is an aqueous solution because it has nitrate in it. I'm interested in the barium part because that's what's going to ultimately precipitate my sulfate ions. So I was told that I had a concentration of 0.200 molar, and that capital M means moles per liter. Okay, so I know I've got to get out of moles of barium, and I've got to get to some sort of volume unit. So I know that I have 0.200 moles of barium, because that was my concentration, in 1 liter of solution. So if you do the math to go from grams of hydrate to moles of hydrate to number of moles of sulfate ions in the hydrate to moles of barium to liters of barium ions that you need to add, you're going to get 0.0254 liters. And the question asks you how many milliliters are you going to have to add. So you're going to have to add 25.4 milliliters of barium sulfate. So that means in order to precipitate out all of my sulfate ions from the hydrate, from this hydrate right here, in order to get all of these sulfate ions out, I need to add 25.4 milliliters of barium nitrate. And the barium ions from the barium nitrate will pull out all of those sulfate ions and make a precipitate. So my answer here is 25.4 milliliters. Now if you'll look right here in question 3, make the same determination for 1.000 grams of alum. So alum's formula is, it's given at the top of your lab. For this second part of number 3 right here, you want to do the same type of process. Figure out if I have 1.000 grams of hydrate, how many moles of hydrate is that? Okay, per mole of hydrate, how many moles of sulfate ions do I have? This ratio right here will still be the same because I'm still going to make barium sulfate as my precipitate. So I need 1 mole of barium for every mole of sulfate ions that I have. And my concentration of barium is also going to be 0.200 moles per liter. So this is going to be the same. So in the second part of the problem, what you're really changing is your starting amount and you're changing the molar mass, because the molar mass of alum is specific to alum. So I hope that helped you. You need to make sure that you have questions 2 and questions 3, both parts, finished tomorrow when you come in, so you know what you're doing in the lab. So you're not wasting time doing calculations that could have already been done. Okay, email me if you have questions, and I look forward to seeing you tomorrow.